Hello and welcome to Relatable Code. In this video, we're going to talk about sealed classes in Kotlin. So let's get started. Sealed classes are one of my favorite features in Kotlin, and I'm going to show you why we need them. Okay. Suppose in the context of our library application, the user has three actions that he can perform. Okay. Let's call them library operations. The first operation he can perform is to borrow a book. The second operation is to return a book, and the third operation is to basically pay a fine if he is late to return that book. Okay. Now, if I want to try to group these actions using an enum, like what we did in the genre, I can do that like this. I can write enum class library operation, and here I can write borrow book, return book, and pay fine. And this is okay until you discover that when you want to have the user borrow a book, you actually want to have a reference to that book. Okay? Now, conventionally, with enums, you can specify a, for example, item, which is a string. But the flaw with this approach is that you have to specify this item at compile time. Which you can't do in this case because you don't know what the user or which book the user will borrow beforehand. Okay, and that's basically the problem behind using this feature of enums, which is properties. Okay, and this is where sealed classes come to the help. You can create a sealed class like this. Instead of enum class, you can write sealed class, library operation. Let's have that without any parameters. And inside that, basically you have to define some classes or objects that will inherit from this sealed class. Okay, we can do that like this. We can write data class borrow book, which extends library operation. Okay, the same thing will go for return book and pay fine. So we have return book and pay fine. And we have a small error here, constructor parameter. Okay, so if the user is trying to borrow a book, you want to have a reference for that book itself. Okay, so you can write val book string, for example. And to return a book, you can have a reference of the book as well, in addition to maybe the condition of that book when the user returns it to the library. Okay, we can have it like this, condition string. And with respect to pay fine, we don't have to define a book here. We can just define the fine. Okay, define the fine. Val fine double, like that. Okay, and this is not possible using enums because using enums you have to specify the parameters of each basically class or enum value which inherits from this enum. Okay, but with sealed classes, you can have data classes which you don't have to specify the value of at compile time, which is before you run your application. Okay, so now I can be more flexible. I can have my borrow book take a book. I can have my return book take a book and a condition. And my pay fine data class can take a fine as a double, okay, as a parameter as well. And that's basically a huge added value with sealed classes because these all share the same responsibility, if you want, of being a library application or an action that the user can take in our library application. Okay, so how can I make use of this sealed class? Let's create a function above these, like fun handle library operation. This function will take our sealed class as a parameter. Okay. Now in this function, I can write when library application. I have to use the is keyword, is library operation dot borrow book or return book or pay fine. And as you can see, similar to enums, the when statement doesn't expect an else here, okay? Because our library operation only has these three data classes that inherit from the sealed class, okay? So I'm sure that library operation can either be borrow book or return book or pay fine. Similar with enums, when you have this genre, which can only be either fiction or science fiction or fantasy, okay? But one more added value here with sealed classes is now if my library operation is a borrow book, I can write print line borrowing a $sign library operation dot book. And which book does this reference? It references the book inside my borrow book data class. How did this happen? Because I'm checking to see if my library operation is a borrow book. So in this statement, in this block of code, I'm sure that my library operation is now a borrow book operation. Okay. So now when I try to reference my library operation, it's a borrow book. Okay. That's basically it. What about return book? Inside return book, I have a book and a condition. Let's try to reference them inside this block of code, which is checking to see if my library operation is a return book. So here I can write print line returning a book $sign library operation dot, and as you can see, I have reference to my book and my condition as well. And condition also $sign library operation dot condition. Okay. And with respect to pay fine, the same goes for our fine, which is a double. So here I can write print line paying a fine of library operation with a $sign, of course, dot fine, which is fine. Okay. So now I have a very flexible function which properly handles every single case of library application and successfully casts my library operation according to which type it basically is equal to or is an instance of at runtime. Okay, because our library operation here is an instance of borrow book or return book or pay fine. Okay, now in my main method, I can create a library operation equals to library operation, for example, dot borrow book, our book to borrow. Underneath that, I can write handle library operation for our library operation. Okay, let's comment out this code and run our application. And now we are borrowing our book. Okay, borrowing our book to borrow. Because our book has this title, basically. Okay, so this print line statement was invoked because our library operation was a borrow book. What if it was a return book and the condition is a good condition? Let's try to run it again. And now we're returning a book. Okay, The same will apply for our pay file as well. So here, 8.0. Let's run our function again. And now we're paying a fine of 8.0. Okay, so now when you trigger this handle library operation, it checks for your library operation and handles every case accordingly. And you really have a lot of flexibility with this, basically. So inside every single block of code, you have access to this data class, which is an instance of this library operation. Okay? As you can see, with sealed classes, you have a lot more flexibility than enums. Okay, with sealed classes, you can have every data class or maybe object that implements this sealed class like this. Our object, it extends library operation. Okay, data classes can inherit from this sealed class, objects can inherit from it, normal classes can inherit from it as well. Okay, extends library operation, which gives you a lot of flexibility. And as you can see now, my one is actually forcing me to handle the other cases, which might be our object or normal classes. Okay, so you basically use data classes normally when you want to have something that has a state and a behavior, which should be a subclass of this library operation. Okay, if you don't want it to have a state and behavior, you can use objects because they don't take parameters. And that's why you really have a lot of possibilities with sealed classes. Unlike enums, where you need to have some constants. Okay, these are basically constants. I'm not saying you don't need enums, you need enums a lot, but you need to differentiate between when to use an enum and a sealed class. Okay, if you know the state of the object beforehand at compile time, like our genres, for example, you use an enum. But if you have some variables like the book and the condition for these data classes, which have the same title, which is library operation, okay, or which share a common action, you need to create a sealed class for that matter. If you find this content to be relatable, please don't forget to leave a like and subscribe for future content, and I'll see you in the next video.